Hey everyone, it's Mr. Montgomery, and if you aren't in my class but you're watching this video anyway, welcome. Maybe you just want to learn a little bit about Isaac Newton, or if you are in my class and you just need a little bit of refresher, or if you're preparing for a test or quiz coming up, you hit the right spot. We're going to go over everything. I might elaborate a little bit more than I did in the classroom. I'm going to try to, and I want to make sure that everyone gets 100 on every test and quiz. That's it. That's all I want. I want you guys to do awesome. I don't want anyone to struggle. I don't want anyone to worry about anything. I always have your back. All right? So today we're going to talk about Isaac Newton and his impact. So after this little video, this video lecture, you'll be able to explain who Isaac Newton was and tell why he is so gosh darn important. All right? But I want you to answer this question real quick, especially if you have not seen this video before, or if you haven't even been in the lesson. Okay? So, what do you think Isaac Newton is known for? Is it his contributions to biology? Is it the creation of the fig Newton cookies? Is it his big ol' white hair? Or could it be contributing to physics? What do you think it is? So, I know you can't really click anything on the screen, but at least just point to an answer. Which one do you think it is? Did you pick one? All right. So the answer is contributing to physics. I know the cookies are super, super tempting to pick, but that's not correct. All right. Now, normally I would show this video, but I don't want to take up too much of the time in the video for this video within a video. You know what I mean? So if you would like to watch it, just go to YouTube, type up Big Bang Theory Fig Newton cookies, and I just thought it was something super funny. It has to do with Isaac Newton, and it explains why fig Newtons have nothing to do with Isaac Newton. They have nothing to do with each other. So if you want to, go ahead on YouTube and check that video out. But let's continue. So here's some background about Isaac Newton. He was born in 1642. That was a long time ago. It's almost 400 years ago, right? And he was born in England, which is Britain, right? England is a little part of Britain. He had so many jobs. Oh my gosh, this guy I feel like he did everything. He was a physicist. He was an astronomer. He was a theologian. He was an alchemist and an author. And also he was one of the first people to say that the Earth was a sphere. It was round. It wasn't flat. And he got so much backlash for this. People would say, you're crazy, you're stupid, you're this, you're that, right? They're just bad-mouthing him because to them it didn't make sense. But he thought a little bit different. So everyone was assuming that the Earth was completely flat because we didn't fall off, right? So they knew that we can be on flat surfaces and we can see that with taking a ball, a marble, or any object, putting it on a table, and it will stay on that perfectly flat surface. But he said, no, it's round, it's round. So when he said it's round, everyone was saying to him, you're nuts. Because if it was round, we would fall off the Earth. We can't stay on something round. That doesn't make sense. But then he ended up figuring out some stuff that actually helped support his theory. So, one of his most famous stories is how he coined the term gravity. All right. So, as the story goes, he was sitting under an apple tree, and it's debated whether the apple fell on his head or fell next to him. Maybe more than one apple fell. Who knows? We weren't there. It was over 300 years ago. Okay. But he saw this apple fall. And he then started thinking, well, that doesn't make sense. Why does everything have to hit the ground? Why doesn't something else happen? And he thought about this for a while. And he just realized that there must be some other force that is keeping us on the planet for things to fall straight down. And then he called it gravity. Now, I do have another video here that I do normally show in the classroom. But, of course, showing a video within a video is a little insane. And I'm not that tech savvy just yet. So, if you would like to see the video, just go on YouTube, type up Isaac Newton gravity, and you'll see this little guy pop up, and he'll explain the whole situation. All right, but gravity is when an object's mass attracts other objects towards it. So this is the whole thought process that Isaac Newton was going through when that apple fell. He was thinking, well, if this apple fell, there must be a reason. And then he started thinking, well, if something's so big like the Earth, there must be another force to bring it towards it. And that's what gravity is. And we're going to go a little bit more in depth about gravity and how it works with every object in just a few more slides. So bear with me. So in that definition, they talk about the word mass. We didn't learn the word mass. We don't know what that is. So what do you think the word mass means? Does it mean how much matter an object has? Maybe. Do you think it's how small an object is? Or how large an object is? So, if you haven't seen this lesson yet, go ahead and pick a choice real quick. You can just point your finger right on the screen if you want. And the correct answer is how much matter an object has. So just because something looks large doesn't mean it's going to have more mass. And just like we just were talking about, mass is how much matter an object is made out of. So how much stuff is it made out of? If you were to look at, I don't know, an empty book bag and a full book bag, which one's going to have more mass? Well, it's going to be the full book bag because it has more stuff to it, right? The empty book bag is hollow. There's nothing inside. Oh, now if you would like, I want you to take a quick second and think of an object that has less mass than you. For example, maybe a pencil. It's made out of less material, so therefore it has less mass. And also think real quick of an object that has more mass than you. Remember, we're talking about stuff that has a lot of material to it, and it is very large. So this can get confusing, like I said with the book bag. Sometimes we forget it all depends how much material is all jam-packed inside of whatever it is we're thinking of. For example, if you want something that has more mass than you could say a car. A car definitely is made out of more stuff than you. It has more mass, and it's way heavier. So another way we can think about it, because if you start thinking about the formula that we will talk about in the next 2 lessons, I believe, we're going to talk about equation, which is force equals mass times acceleration. They all use measurements, and mass is measured in kilograms, okay, or kilos, as you might hear in shows and movies. So if it weighs more, it most likely has more mass. All right, let's continue. And there are some very, very important terms we need to think of and learn before we go forward with any other lesson. Like first, force. Force is an energy that causes movement. Now, I put Yoda in here just to connect the dots for you guys. They can make stuff move in Star Wars, right? But then they also do other stuff that doesn't make sense with the definition of force, right? We're talking about moving objects. So, think about when you're at a bowling alley. If you've ever gone bowling and you pick up that bowling ball and you throw it down the lane, you are using force to move that bowling ball down the lane to knock over those pins, right? Or if you're playing baseball and you're trying to hit the baseball as far as you can, if you want to hit it super far, you're going to use a ton of force to try to whack that ball out of the stadium. But you can also use just a little bit of force and gently tap the baseball so it doesn't go that far, right? We've seen that happening in baseball all the time, and we call it bunting, where you just kind of use a little bit of force to let the ball bounce off the bat. It doesn't go far, and sometimes it really throws people off. So just remember, force, you're putting energy in to cause movement. So let's look at this picture real quick. We got 3 things here. So we already talked about mass of an object, right? How heavy something is, how much stuff it's made out of. And also we've learned about force, which is causing movement. Now, if I wanted to put these objects in order from the easiest to move, needing the least amount of force, which object would that be? And I want to put the 1 over top. So where should I put the 1? Is it going to be this marble? Is that going to need the least amount of force? Is it going to be these balloons filled with helium? Will that need the least amount of force to make it move? Or is it the bowling ball? Will that need the least amount of force to make it move? So just point at the screen real quick to one of those 3 pictures. All right, 3, 2, 1. It's the balloons. Now, like I said, just because something might look bigger, for all we know, these balloons are bigger than this bowling ball, but it does not mean that it has more mass and would need more force to move it. We all know balloons are super light, right? Because it's this little piece of rubber that gets blown up into these big, cool shapes. And it's the air that's just making the rubber expand. If you pop that balloon and ball up that rubber balloon after it's popped, you can get it the size of a pea, right? It's super tiny. It doesn't have much mass to it. But what about the 2? Where would the number 2 go for the second most amount of force to move an object? Okay, so after the balloon, what would need a little bit more force to move? Not the most, just a little more. Is it going to be the marble or the bowling ball? All right, go ahead and point to one. And it's the marble. The marble does have more mass than these balloons. It's a little bit heavier. If you were to measure it, it would only weigh maybe a couple grams, maybe 2 to 3 grams or something. It's not that heavy, but it is heavier than these balloons, right? Because they don't really weigh much. And then finally, this bowling ball, this 3 is going to stay right on it, because a bowling ball can be anywhere from, not grams, but pounds, right? 6 pounds to 15 pounds. They're super heavy. You need a lot of force to throw it down that lane at the bowling alley to knock over as many pins as possible. Okay, and last, motion. Motion is the process of moving or changing position. So yes, if you run, that is, of course, motion. But you don't have to run to have motion happen. You could just wave your arm, right? And you're just changing positions at that point. That's it. A clock shows motion going around. A ball rolling shows motion. And, a big grandfather clock with this swinging pendulum shows motion as well. Okay, so that's actually it for this little mini lesson on Isaac Newton. We learned a little bit about Newton, some huge ideas that he had, and some other important concepts that are really going to help us understand his 3 laws of motion that we're going to dive into in the next 3 lessons, actually probably 4 lessons. All right, so I hope this helped. If I would love some positive feedback about what could help you guys more in these videos. I need some ideas. I am willing to do whatever it takes to help you guys out. So just let me know. You don't have to leave a comment on here, but you can just tell me in the classroom. All right? So have a great night, guys, and I will see you next time.